Hi, welcome back to my channel Reagent. In this video, I'm going to discuss how to write molecular electronic configuration in nitrogen molecule. This is the topic from chemical bonding and molecular structure. Here I'm going to detail explanation of this N2 molecule according to molecular orbital theory. So, molecular orbital theory Molecular orbital theory explains the nitrogen molecule formation and its properties. Now let us discuss in detail of this N2 molecule. As you know that nitrogen molecule is formed from two nitrogen atoms. When two nitrogen atoms combine, so their atomic orbitals, so that having same energy and same phase also overlap to form molecular orbitals. There are two kinds of molecular orbitals are formed when their respective atomic orbitals overlap. So molecular orbitals having lower energy, so which we call bonding molecular orbitals we say, and second type is said to be anti-bonding molecular orbitals we call. Generally, the orbitals, molecular orbitals, bonding molecular orbitals have so lower energy, and whereas anti-bonding orbitals have higher energy, we say. So, when two nitrogen atoms, their respective atomic orbitals. So, if you look into the configuration of nitrogen atom atomic number is 7. So, their electronic configuration is 1s2 and 2s2 and 2p3. Similarly, another nitrogen atom also having configuration, similar configuration 1s2, 2s2, 2p3. So when two nitrogen atoms combine, their respective orbitals like, so 1s will overlap, 2s will overlap, 2p will overlap. Result, so there are two kinds of molecular orbitals are formed, antibonding and bonding orbitals we say. So here, since 1s orbital is very close to the nucleus, I am taking that outermost shell, 2s orbital and 2p orbitals. So as you know, the 2s orbital having one nitrogen atom of 2s having complete filled electrons, so paired electrons, 1s, 2s2. If you take like this, so when this nitrogen atom combined with other nitrogen atom, so electrons also redistributed in their respective bonding and anti-bonding orbitals. So since the bonding molecular orbitals having lower energy, electrons as per the Hund's rule, so they occupy in the ground state, so and they pair up according to Hund's rule in the ground state bonding molecular orbitals. Rest of the electrons will move to anti-bonding orbitals, molecular orbitals. So generally, anti-bonding orbitals are indicated with a star sigma. So and bonding molecular orbitals indicate only sigma. So here we can write sigma 2s2 and star sigma 2s2. So, and coming to 2p orbitals of nitrogen atoms. So 2p contain 3 electrons. You can write 3 electrons in 2p orbital 2p3. As you know that 2p orbital is divided into 2px, 2py and 2pz. So these are 3 degenerate orbital having same amount of energy. So when two nitrogen atoms combine, so and one of the p orbital, degenerate orbital, so overlap, end on end overlap and result to one sigma bond. Rest of the p orbitals will form pi bond each. Hence, so when 2p orbitals of one nitrogen atom combine with 2p orbitals of another nitrogen atom, so there are molecular orbitals pi 2px, pi 2py, next sigma 2pz. If you take 2pz that form sigma, rest will form pi bond. Or if you take 2px will form sigma, rest of the 2pyz will form pi bond. So you can take any direction. So here now the electrons also redistributed into the bonding orbitals. First the electrons occupy pi 2px, and next electron comes into pi 2py, and similarly 2pz sigma 2pz1, and rest of the electrons, as per the Hund's rule, electrons pair up. So now three electrons of one nitrogen atom and three electrons other nitrogen atoms, they occupy the ground state in molecular bonding orbitals, and so no electrons are left to occupy the anti-bonding orbitals. So anti-bonding orbitals, sigma star to be z, and pi star to be x, pi star to be y, complete vacant. So in nitrogen molecule, nitrogen anti-bonding having less number of electrons, whereas bonding electrons having more electrons. So since anti-bonding electrons are so empty, anti-bonding electrons are empty, that's why nitrogen molecule is stable, N2 molecule is stable in the atmosphere, and even it is it having inert properties also. And if you look into the bond order can be calculated as, so number of bonding electrons minus anti-bonding electrons upon 2. So bonding electrons, so how many bonding electrons you have to count? So sigma 1s2 and sigma 2s2 and sigma 2pz2, and also 2px2 and pi 2px2, pi 2py2. So there are total number of electrons. Bonding electrons how many? 10, and anti-bonding electrons are 4. So total 6 upon 2, and there are so bond order will be how much? Between nitrogen molecule bond order is 3. So since bond order is very high, bond enthalpy is very high, so that's why nitrogen molecule is more stable in the atmosphere, and it is diamagnetic because no electrons present in the antibonding orbitals. Thank you.